So last lecture we have been talking about cardiovascular system, about conductive system of the heart, and I told you that when we are talking about properties of cardiac muscle, we say that properties includes automatia, excitability, conductivity, and contractility. And we have been talking also this time that when we are talking about automatia, this is exclusive properties of cardiac muscle only. And automatia working because we have a conductive system of the heart. Conductive system of the heart working like autonomic generator of electrical impulses inside of our heart. Main structure of conductive system, how I told you before, it's a sinoatrial node, atrioventricular node, bundle of His, bundle branches, and Purkinje fibers. Important, how is it working? I explained you also, because we say that we have specific mechanism generation of action potential for conductive system of the heart. And here we have specific phase of action potential. This specific phase, name it as SDD phase, slowly diastolic depolarization. Slowly diastolic depolarization works because of T-type of calcium channels and funny sodium channels. This type of channels induce for us depolarization from -60 till -40. From the moment -40, we have opening of L-type calcium channels, and this time we have a high-speed depolarization phase or rapid depolarization. Repolarization phase happen as usually we have repolarization because of moves out of the cell potassium ions, and plus ions moves outside, and we turning back again to the first line from where again we have automatically SDD depolarization. When we are talking about ECG, electrocardiogram, we say that ECG, this is registration of electrical activity, what is going on inside of our heart. And ECG, for registration of ECG, we have 12 leads. 12 leads help for us registrate electrical process in the heart in different axes and different direction. When we are talking about main description of ECG, we can say here that ECG consists of P wave, QRS complex, and T wave. Also, on the level of isoline, we have segments. Segments, name it like PQ segment and ST segment, and also TP segment, because all this composition all time same every heart cycle. When we are talking about different part of our ECG, we are talking that P wave is responsible for excitation process in SA node, in the first node, and process of depolarization of our atriums. You see here red color, here red color. Next one, QRS complex, responsible for the depolarization of our ventricles. And T wave, we have registration when we have repolarization of our ventricles. From ECG, we can find with you What is main pacemaker of the heart who generate our heart rhythm? It will be a sinoatrial node, or maybe sinoatrial node doesn't work and beginning to work other one. Sinoatrial node normally is the main heart pacemaker. And how can we understand SA node works or doesn't work? Important sign here that we have QRS complex. This QRS complex follows every P wave. P wave should be obligatory positive in first, second, and third standard leads. And also for us is important frequency of heart contraction. If I will drawing for you like continuation of ECG, we will have again P, Q, R, S, and new T, and again new P, Q, R, S, and so on. Why I'm drawing this? Because, for example, by a measurement of distance between two R wave, we can calculate time duration by this distance, and when we find duration between RR interval, we will find with you duration of one heart cycle. From here, we can calculate what is a heart rate for this person. Okay. When we are talking about electrical process in typical cardiomyocytes, we are talking about this shape of action potential. Again, I would like to remind you that normally action potential has like that shape. But for typical cardiomyocyte, we have new phase, what we not have before. This phase is named as Plato phase. Plato phase. Normally it should be like this. But here we have Plato phase when we not have immediately repolarization, but we have like delay for repolarization for some needs of our heart. Why? What is going on here? When we have generation of action potential in conductive system of the heart, conductive system induce irritation of typical cardiomyocytes. And here we can imagine here happened irritation. As a result, we have with you phase of depolarization. Phase of depolarization working because of enter of sodium ions, as usually we could see for every action potential, how we have been studied before. But as next phase, this is like start of repolarization. After and repolarization because of movements of potassium out, chlorine in, and we have like little bit decreasing of membrane potential. But it's not turned to the back because on the face of Plato phase, we have entrance of calcium. Calcium is plus charged ion. That's why calcium doesn't give for this Plato phase, moves to the down and induce fixation of this Plato phase on the some high level. What is going on during the entrance of calcium? When we are talking about normal skeleton muscles, we say everything is going on by next way. Action potential, sorry, not nice. Action potential should be after action potential will be happened normally, should be happened muscular contraction for normal skeleton muscles. But source of calcium for normal skeleton muscles, this is inside of the fibers from sarcoplasmatic reticulum. There we have special cistern. Inside this cistern we have calcium, and calcium should be released and moves to troponin tropomyosin system. But when we are talking about cardiac muscle, source of calcium we have outside of cell. And when we have plateau phase, calcium moves to the cardiomyocytes. At the same time, we have muscle contraction. This is important. Why is important? Because when we are talking with you about normal skeleton muscle, here, like will be the next way. If this moment we will make with you irritation, or this moment we will have with you tetanic contraction. So if new and new irritation will become, it will be induced contraction but never relaxation. And as a result that we will have new and new contraction, it will be induced tetanic contraction. If it will be happen with the heart will be stopped and a person will be die. That's why we have protection for will be not happen tetanic contraction. This protection, that contraction of cardiac muscle arise during action potential, not after but during. And if you remember, during action potential, we have special phase. It's named as absolute refractory period. Absolute refractory period. Absolute refractory period, it means that during this period, new irritation never can induce any new reaction. And because absolute refractory period, if any irritation will become any period of this action potential, new irritation and new contraction will be not rise. That's why our heart absolutely protected itself from tetanic contraction. This is exam question. That's why I pay so much attention for this moment. How I told you before, here we can see with you absolute refractory period and relative refractory period. During relative refractory period, already we can induce new contraction, but it will be not important because we will have already phase of relaxation. That's why we will not have any problem with new contraction. Again, I show you, underline for you how is going on in skeletal muscle and cardiac myocytes. Again, skeletal muscle, first action potential, after contraction. But cardiac myocytes during action potential happen contraction. That's why, again, here possible tetanic contraction, but here is not possible because every moment of this contraction we have with you absolute refractory period. And only here, but it's already not important, able to happen new contraction. Cardiac cycle. Cardiac cycle, how I have been talking before, I was talking that last lesson that we have like cycle. If we will imagine that this is our heart, first we have contraction of atriums, after ventricles, after diastole, general diastole or general pulse. If we will imagine that this is our cardiac cycle, we say that happen contraction of atrium, contraction of the heart named as systole. dilatation or relaxation of heart, named as diastole. And what do we have with you? We have first systole of atriums. If this heart will be like that. Systole of atriums. This time we have relaxation of ventricles. Only systole of atriums is finished. Started systole of ventricles and relaxation of atriums. After we have general pause or general relaxation of the heart. And again, we have contraction of atriums, again, contraction of ventricles. Okay. If we're talking about cardiac cycle, we should say that cardiac cycle consists of starting with from the contraction of ventricles, tension period, and period of ejection. Tension period in the ventricles, it means that we have excitation of muscle cell of ventricles and beginning isovolumetric contraction. It means that tone of the muscle is increased, but length of the muscle not change. Second phase, this period of ejection, when our heart will be pumped blood to the, for example, aorta. Left, if we're talking about left ventricle push blood to the aorta. And this period named as ejection. How is it happened? Changed length of the muscles are contracted, and we have pushing of the blood to the vessels. First, it's rapid phase, it's easy because aorta is empty and pressure there is low. So first phase is rapid. Second phase will be reduced because here pressure will be up and it's not so easy already to push other blood. Third period, named as protodiastolic period. This time, blood from the ventricles moves to the aorta and walls of the aorta are closed. Walls are closed, and we hear with you second tone of heart work, or second sound. If we will listen how a heart is working, if we will listen to, we can hear two sounds by our ear. This sound, in English terminology, name it as lab-dub sound. In Ukrainian terminology, we not say lab-dub, we say first tone, second tone. But in English terminology, they say lab-dub sound. If you will listen by stethoscope, phanendoscope, heart beating, you will hear like this sound.
Mhm.
This is first and second sound, or lab and dub. First sound we hear when happened here tension period, when these walls, look, this and here walls will be closed first, and contraction after we increase tone, closed like it was like that, and they will be closed. It will be first sound, lab sound. Second sound we hear when blood will be injected to the vessels, to the arteries, and blood moves to up after blood want to turn back. And when blood try to turn back, will be closed semilunar valves. Semilunar valves will be closed. And again, we hear new sound. This is second sound, or dub sound. After we have relaxation. First, it will be isovolumetric ventricular relaxation. So again, without change of volume. After ventricular filling, because our heart will be relaxed and all blood so easy moves from atriums to ventriculars directly. So easy. And last phase, will be contraction of atriums. Everything what still have in the atriums will be pushed finally in our ventricles. And again, we have new cycle, how I have been described before. Okay. Cardiac output. Cardiac output is defined as amount of blood pumped out each of ventricle per minute. Here we should know the cardiac output depends on heart rate and stroke volume.
Hello. Sorry for being late. I had really bad
Oh,
internet connection.
hello, join us, welcome.
Thank you very much.
Stroke volume, this amount of blood which pumped by heart by one cycle. And stroke volume depends on next parameter. Preload, how much blood come in the heart. After load, this depends on peripheral resistance of the vessels, I will explain now, and contractility of the heart, properties of heart muscle. When we are talking about regulation of heart activity, we say about three mechanisms of regulation, three main mechanisms. First, this myogenic regulation of the heart or self-regulation of heart contraction. Second, it will be humoral regulation. Third, it will be neural regulation, or second neural, third humoral, doesn't matter. First one, myogenic regulation, we say that as usually this regulation works during state of rest. When we are rest, when not have something, some troubles, activity or something, this time working myogenic regulation. And here we have like three mechanisms. First of all, what you should know and memorize, this preload and afterload mechanism. It's so easy if you will look this picture. I so like this picture. Look what they say. Preload. Then more blood will become to the heart. Then more heart will be straightened. Then more straightened muscle. Then more will be contracted. That is all. This preload law, or it's named also Frank-Starling law. Frank-Starling law. So if you will have this question about Frank-Starling law, you should know that then more straightened muscles, then more they will be contracted. That is all. If we are talking about afterload law, this other question, how is it working? It's working by the next way. Then more will be peripheral resistance of the vessels, arteries. Then more heart for more difficult will be pushing by heart blood out. That's why blood will be more contracted if pressure in the arteries will be up. Sometimes we are talking about, for example, atherosclerosis. If we are talking about atherosclerosis for some adult person or 40, 50 years old, as usually this time beginning this problem, atherosclerosis will be closed surface of aorta, and for heart will be not so easy moves out. Elasticity of aorta will be decreased also, and it also will induce problem. That's why also if here pressure will be up, contraction of the heart will be also up. And we can hear that for aged people, like old people and some years old people, they have increasing muscle and volume of left ventricle. Why it's happened? Because they have problem with aorta, with arteries, because of atherosclerosis, and heart need more working for pushing blood outside of the heart. This is self-regulation of the heart. Okay, next. When we are talking about neural regulation, of course, we are talking about sympathetic and parasympathetic system. Sympathetic and parasympathetic system for the heart activity working like opposite each other. Sympathetic system, this sympathoadrenal system, the system of the stress. And when we have activation sympathetic system during some stress, during physical activity, during emotional stress or something what is going on with our body, we have activation sympathetic nervous system. Sympathetic nervous system by the sympathetic nerves has influence on the conductive system of the heart. First of all, has influence on a sinoatrial and atrioventricular node, and also has influence on the contractility of our heart muscle. How is it working? Through the beta adrenal receptors. On our conductive system, we have beta 1 adrenergic receptors. Beta 1 adrenergic receptors increase membrane permeability for calcium ions. And we say with you, then more calcium will be, for example, look, this system of rest, for example, if calcium more quickly will be entered, this phase SDD will be changed like this, shorted, and more quickly everything will be happened. It means that heart rate will be increased. If norepinephrine or epinephrine will has influence on the normal cardiac muscle, force of heart contraction also will be increased. When we are talking about parasympathetic system, in this case, we are talking about nervus vagus nerve and influence through the acetylcholine, important muscarinic acetylcholine receptors. Muscarinic acetylcholine receptors increasing membrane permeability for potassium ions. If potassium ions, it means that again this is like state of rest. If we will have activation of potassium, it will be more long time for SDD phase, and that's why heart rate will be decreased. In most of information from different scientists, we have information that parasympathetic system like not have a direct effect for the heart muscles, only for the conductive system of the heart. Okay. If we are talking about humoral factors and humoral regulation of heart activity, about main factors, we should say about acetylcholine and potassium. They have negative effect, chronotropic, inotropic, dromotropic, and bathymotropic. It means that decreased frequency of heart rate, velocity of signal, decreasing force of contraction, and opposite positive effect we have under influence of epinephrine, norepinephrine, hormones T3, T4, thyroid hormones, and ions of calcium. Then more calcium will be entered from outside, then more intensive we will have heart contraction. T3, T4, I would like to remind you that T3, T4, these thyroid hormones, they not have a direct effect on the heart muscle, but this type of hormones, they increase production of adrenal receptors and sensitivity to epinephrine, norepinephrine for the heart muscle is increased. That's why work of the heart also will be increased. When we are talking about work of cardiovascular system, we should say that we have two main circle of our blood circulation. This small one or pulmonary circulation and a large one or systemic circulation. 1 second, I would like to show you some video. I would like to show you how or remind you how is working our circulatory system, small and a large circle of cardiac circulation. Large one or visceral and pulmonary one. By the pulmonary circle, we have reaching our lung blood without oxygen, but with carbon dioxide. In the lungs, we have gas exchange, we have releasing of carbon dioxide, and our blood reaching by oxygen. And visceral one, large one, you see that oxygenated blood moves by all our organ everywhere, and we have transportation of oxygen to all our tissue and collection of carbon dioxide. Okay. So the same on the my scheme, you could see that here we have vessels which induce transportation of oxygen, vessels transportation deoxygenated blood with carbon dioxide, and vessels involved in gas exchange. Important to underline that gas exchange happen only in capillaries. When we are talking about different type of our vessels, we should say about arteries, arterioles, capillary, venule, and veins. Let's look, here is nice scheme where we have description, different components of wall of our vessels. Here you could see that everywhere we have endothelial cells. Artery has high component of elastic tissue. Artery and arterioles, high component of smooth muscles and fibrous tissue. When we are talking about vein, important to say that vein not have so high quantity of smooth muscle layers, but they are elastic. In the capillaries, we not have not elastic tissue, not smooth muscles, only endothelial cells. That's why only in capillaries we can have with you exchange of fluids and exchange of gases. We have classification of blood vessels. How I told you, like artery, arterioles, capillaries, this anatomical classification. If we are talking about functional classification, we should say other. Vessels of compression chamber with aorta and arteries with large diameter. Precapillary resistible vessels, these arteries of little diameter and arterioles. They create the higher resistance in our blood circulation. Vessels of exchange, these capillaries, post-capillary resistible vessels, these venules, they also can regulate resistance of blood flow. And capacity vessels, they are veins, which have the least resistance and most capacity for expansibility and blood depaneating. The main volume of the blood every second of our life we have inside of our capacity vessels, inside of our veins. Let's look. Flow velocity depends on flow rate and cross-sectional area. Then more cross-sectional area, then flow velocity will be what? Low or high? Then flow velocity depends flow rate and cross-sectional area. Then cross-sectional area higher. So flow velocity will be
Decreased.
Decrease. Right. Why I show to you? Look, cross-section, for example, aorta here, and cross-section of all capillaries will be here. What it means? It means that the lowest speed transportation of the blood we have in capillaries. In capillaries. Higher speed we have in arteries, less speed in veins, and the slowest we have in capillaries, because here we have the biggest general cross-sectional area. Okay. Also, we have with you formula. If we will calculate linear velocity of blood movements, we could say that it depends on cardiac output and vessels cross-section square. Cardiac output depends on differences of pressure and resistance. Resistance depends on viscosity of the blood, depends on length of the vessels, and depends on radius of vessels. If you will have question and you should answer, the most important factor for resistance of the vessels, you will answer this is radius of the vessels. The most important, this is radius of the vessel, because you see which level, which degree we have here. Okay. When we are talking about flow in our blood vessel, we should say that normally, in perfect way, our blood should be moved according to laminar blood flow. You see? So it will be like equal everywhere. But sometimes it's happened turbulent flow, blood flow. When it's happened, turbulent blood flow happened when, for example, again, atherosclerosis we have in the vessel, or we have changes from small diameter to higher diameter. If blood flow, for example, some bifurcation of vessels or something like that, this case, blood flow happened turbulent. It's not like linear, not normal, it's like turn. Only after it will be will have stabilization. Let's talking about measurement of blood pressure. When we are talking about blood pressure, we know with you that blood pressure normally consists of two values, this or two numbers. These numbers is systolic and diastolic numbers. Systolic pressure, this pressure, what we can register in our arteries during heart systole. It means that systolic pressure indicate work of our heart. Diastolic pressure we can register in our arteries during heart's diastole. So it means this pressure created by blood vessels walls and by blood flow without participation of the heart. When we measure by normal way of our blood pressure, what is happen? We are using special cuff. In the cuff, we created pressure higher than in the vessels, and blood flow stopped. When we beginning to decrease this pressure in the cuff, first we hear and first we can restate renewing of blood flow when we have heart systole. When blood pressure will be the same and we can hear heartbeats by stethoscope. But when blood pressure in the cuff will be equal to blood pressure in the arteries, this moment heart rate and sound we stopped to hear. And this number will be equal to diastolic blood pressure value. Normally, systolic pressure equal from 100 till 140, even right to say not 140, normal we calculate 139. Normal diastolic also from 60 till 89. 90 it's already higher than normal. Pulse pressure, what is it mean? Not enough only that blood pressure will be according this norm, how I told you. For example, what is the normal value you know for the blood pressure? What is the normal blood pressure? Tell me numbers. Usually we say that 120 on 80, right? 120 on 80, and we say as usually if you have like this blood pressure, you could be a pilot. It means that your cardiovascular system works fine. Why I remind you this 120 on 80? This is important number for memorizing normal pulse pressure. Pulse pressure, this difference between systolic blood pressure and diastolic. Systolic blood pressure minus diastolic blood pressure. If 120 on 80, what is pulse pressure in this case?
It will be 40.
Right. Why I show you that? Important to remember. Look, for example, one person has pressure 130 on 60. According to the norms, we can see that systolic is what? Normal or not?
No.
Why? Till
Oh, no,
139.
normal.
Normal. Yeah,
It's
normal.
yeah.
Diastolic also is fine, right?
Yes.
Yes, but is it fine will be for person 130 by 60? It will be not fine. This person will be bad feeling because pulse pressure,
yeah.
you see, so huge.
Mm-hmm.
This is not normal. As usually, this story happened when and I say you that systolic responsible for heart, are diastolic, but diastolic responsible for vessels. And it's usually this story happen when vessels too much dilated and heart try to make compensation. Heart rate so much increase this time, and this systolic pressure is up for compensation of general pressure. Other story could be 100 by 85. You see what is here? Like also 100 is could be fine, 85 it's normal, but again so small difference. Pulse pressure here how much?
15.
15. It's so small. As usually this story happened because vasoconstriction or vasospasm. And this case, this person will feeling headache as usually, will be bad feeling, can be have trembling in the hands and so on. Only one way for help for this case, this using some spasmolytic treatment for take out spasm of vessels, and this case will be decreased this pressure like to 60 and 100 on 60, it will be absolutely fine. Here we have increasing heart rate and also not good feeling. That's why what I want to show you, that even due to norm of blood pressure, we can not comfortable and not good feeling because of this change. And my recommendation for all my students, you should have tonometer for measurement your blood pressure every moment. And even if you're not old, even if you are young, so often can be happen situation like that or like this. And this case, we can help to us by special pills and improve our health and our feeling. Mean arterial pressure, this like average between systolic and diastolic, normally from 65 till 110. Mean arterial blood pressure we can calculate according to formula. Diastolic blood pressure plus pulse pressure divided by 3. Average pressure, this like mean arterial pressure. This is significant because here we have difference between main arterial pressure and venous pressure that drives the blood into the capillaries. Regulation of vascular tone. When we are talking about vascular tone, we also have like and for heart, local regulation and systemic regulation. When we are talking about local regulation, we should say about myogenic and humoral regulation. Local by vessel's wall. Systemic, this is systemic influence from nervous system and by humoral system. When we are talking about, 1 second, I will. When we are talking about a local regulation, I will tell you a few words about it. Myogenic regulation will be happen by next way. If we will measure tone of vessel in the inside of the body, this vessel will be, I will show you, for example, with different diameter. First, if we will measure inside of the body, for example, diameter of the vessel will be like that, because vessel will be under local regulation and under systemic regulation from humoral and neural factors. But if we will separate vessel from the body, humoral and neural regulation we will lose. This time will happen dilation of the vessel. Dilation, or if, for example, we will delete it influence from nervous system. 1 second. Nervous system. If we will delete this influence, we will have decrease of tone vessels. But if circulation will be continue, vessel will save some diameter. If circulation will be stopped, it means that if we will not have irritation of muscles of the vessel, this time will happen increase of diameter. It testifies that even if we will delete it central neural influence on the vessel, we save general myogenic tone, general myogenic regulation. It's working by the next way. When blood flow moves by vessels, vessel's wall is straightened, and when we have, as all muscles, when muscles are straightened, they will induce contraction. It's named myogenic, local myogenic regulation. But also we have humoral local regulation. It depends on endothelial cells. Inside of our vessels, we have internal layer. It will be layer of endothelial cells. Endothelial cells able to release more than 20 different substances which can influence, induce inflammation on the vessel's tone. And this will be different substances like endothelin, thromboxane, prostacyclin, and different substances which can change tone of vessels. But this is for local regulation, not for the central one. When we are talking about regulation of systemic blood circulation, here is important to say the next way. We have rapid nervous regulation, middle regulation, and slow prolonged regulation. Rapid nervous regulation, we are talking about pressuric and depressuric reflexes. Pressuric and depressuric reflexes, they are started from specific receptors, I will show you now, and induce activation of sympathetic and parasympathetic system. Middle regulation of arterial pressure happen because of vasopressin, hormone vasopressin, or antidiuretic hormone. This hormone of hypothalamus hypophysis system. And vasopressin induce reabsorption of the water and increase volume of circulated blood, and also induce tone of vessels, increase resistance, and has influence on the tone of veins. And slow prolonged regulation with participation of renin-angiotensin system and aldosterone. They also have influence on regulation of vessels resistance. All of these factors can change cardiac output. And let's start from depressoric reflexes. It's working by the next way. Higher centers like our brain cortex able to influence on our hypothalamus. Hypothalamus has influence on sympathetic and parasympathetic system. When we are talking about activation of sympathetic system, this case we have increasing of heart rate, how we have been talking before, and increasing blood vessels tone. Parasympathetic system has a directly influence only on the heart, but without influence on the vessels tone. This is important. Sensors which are responsible for sympathetic and parasympathetic system activation. We have with you special cardiovascular center in the medulla. Afferent signal come from special receptors. Special receptors we have with you in the carotid sinus and in the external carotid artery. We have there chemical receptors, chemoreceptors, and baroreceptors. Let's look. Under influence on chemoreceptors, for example, we can have increasing of carbon dioxide or decreasing of oxygen, and this signal will be moved from chemoreceptors to our brain. Here we have activation of sympathetic nerves or parasympathetic nerves. This picture from baroreceptors here is working by the next way. If blood pressure, I will show you. If blood pressure is decreased, baroreceptors doesn't receive signal, and we have activation of sympathetic nervous system. Sympathetic nervous system. If blood pressure is up, it means that we should decrease blood pressure. This case, we will have activation of parasympathetic system. Parasympathetic system. These baroreceptors and chemoreceptors, the same area we have chemoreceptors. They are sensitive, how I told you, to oxygen concentration, to carbon dioxide concentration, H+ concentration. And if H+ and carbon dioxide is increased, it's signaling to the heart for increasing heart rate. Let's make a 5-minute break.
Okay.
The respiratory system. When we are talking about respiratory system, a little bit remind you anatomy. We have the upper respiratory system and lower respiratory system. Upper respiratory system consists of nasal cavity, nostril nasal cavity, oral cavity, pharynx, and larynx. Lower respiratory system consists of trachea, bronchus, and lungs. All components starting from the nostril until the bronchus we are named as respiratory passageways. Gas exchange happen only inside of the lungs. This is important moment. Second important moment, when we are talking about steps of respiration, here we should say, because as usually when we are talking about normally about respiration, we are talking that it's like include inhale and exhale, or inspired and expired of expired of the air, but it's wrong because it's only first step of respiration. Inspiring and expiring of the air, name it as ventilation. Second step, when gases enter to our lungs, happened gas exchange. Oxygen moves to the blood and carbon dioxide released from the blood to the lungs. Third step is gas transport. It's happened by circulatory system. Fourth step is gas exchange with between blood and our tissue. This time gas oxygen moves to the tissue and carbon dioxide moves out the tissue. And last step, this oxygen utilization, carbon dioxide production. This is the main aim why we are breathing with you, because by this way happen cellular respiration. How I told you before, why do we need breathing? We need breathing, first of all, for consumption of oxygen. Why do we need oxygen? We need oxygen with you for production of energy, for production of ATP. This is only one reason why do we need oxygen. And also what is important, that we have to release carbon dioxide, because like this is product of metabolic exchange. Let's move one by one about function of different parts of our respiratory system. Nasal cavity. First of all, this main passageway for respiration. Here also we have receptors for smell and identification different smells. Here we have filters incoming air from large foreign materials. Also here we have moistness and warmth incoming air. That's why always like adult people say for children, in winter time, in cold time, you should breathing through the nose, because here we have warming incoming air. And also our nose working as resonating chambers for our voice. You very good know that when our nose is closed, our voice is changed. It could be sound like my voice right now. That's why it's also important. Next part, I would like to talk with you about larynx. Larynx consists of cartilage, different cartilage, and larynx has stable shape and never changes. Inside of our larynx we have visual vocal cords. Because of presence of vocal cords, we are able to talking and create any voice, any sound. Also, here we have protective mechanism and protective receptors. After irritation of these receptors, we have with you coughing if some particles moves inside of our larynx. Movements of vocal cords, you can see that this shape and this position of our vocal cords when we are talking, when we are speaking, and this one when we have normal respiration without any sound, Here we are breathing, here we are talking. And interesting one, this is whispering. Sometimes when we have sore throat and we have problem with our voice production, we are trying to like save our vocal cords and begin to talk so not loud like whispering. But I would like to underline for you, when we are whispering, this is the most hard position for our vocal cords. And if we would like to save our vocal cords, we should never whispering this time. Next, after our larynx, we are moves down, we have with you trachea. Trachea is also system of cartilage. And also always I would like to compare this cartilage structure with our vacuum cleaner tube. Why? Because they are create for us strong tube with saving of shape, but at the same time we have this tube is elastic and we can move our neck without stopping of our breathing. After trachea, we have with you bronchi. Bronchi divided for right and left one. Bronchi divided for bronchioles and create for us like bronchi tree inside of our lung. In the end of bronchioles or terminal bronchiole, we have with you alveoli. Alveoli create for us our lung. Also important to say that our lung covered by two pleura, parietal pleura and visceral one. Between parietal and visceral pleura, we have with you cavity, pleural cavity with a special liquid. Our alveoli is they are so thin, and so tender tissue. Through this tissue, we are able to make gas exchange. And important that here we have so high quantity of vessels, capillaries. Because of these capillaries, we have with you gas exchange. Also important to underline that internal surface of our alveoli covered by surfactant. Surfactant created by special cells, cuboidal epithelial cells. They are scattered in alveolar walls. Surfactant is detergent-like substance which is secreted in fluid coating alveolar surface, and main function of surfactant is decreasing of tension. And without it, walls would stick together during exhalation And for example, if you know about some problem with premature babies, they have problem with breathing because lack of surfactant. Their lungs cannot be open and working clear. Important moment also that how I told you, between two pleura we have surface, and important that this surface created pressure. This pressure is negative. It means that this pressure less than our atmospheric pressure, which have in our lungs, in our alveolus. If this pleura will be damaged and pressure will be equal to the atmospheric one, lung will be closed and will be not able to work. Inspiration and expiration is possible only because of working our respiratory muscles. Without respiratory muscles, respiration is not possible also, because opening and or increasing and decreasing volume of the lung possible only because work of our respiratory muscle. Respiratory muscle, this is diaphragm, and intercostal muscles. When we have inhalation, diaphragm contracted and moves to the down, ribs moves out, and volume of the cavity is increased. When we have expiration, diaphragm moves to the up and ribs moves to the down and volume is decreased. We have exhalation. I would like to show you a short video for the explanation and spatial model how is working our lungs. Here you will see this model demonstrated with using of lungs of frog, but by this way working our respiratory system. Look, this like our lungs cavity. I told you that lungs are isolated and air can be moved only through the passageway. Other way, it's not possible come to thoracic cavity. This membrane, rubber membrane, equal to work of our respiratory muscles. And how is working? Or you can more easy to imagine if you will use it. This is diaphragm. When diaphragm moves to the up, volume of cavity is increased, lungs are open. When moves to the up, this time volume of cavity is decreased and lung closed. Let's look. Interesting moment, I will tell you also that using of diaphragm is usually used by men but not by women. For women, it's usually we can illustrate working of intercostal muscles, only diaphragm for men. That's why men respiration is more effective than women. Also, when we are doing some physical exercises or have some loading upside our body, we have accessory muscles of respiration. They include and abdominal muscles and muscle of our back and even muscle of our arms like trapezius muscle, rhomboid major muscle, and so on. This Donders model, how I showed to you few seconds ago. And how I told you that when we are talking about men and women breathing, that man type or male type, they are using muscle of abdomen and diaphragm, but women using costal thoracic muscle. It's of course it depends on special construction of women body, because inside of women should be growing fetus, should be growing baby, and we cannot change for 1 second type of our respiration. That's why we are protected, and for women normally diaphragm is not working. But if during training, for example, physical exercises, we can control work of our diaphragm and induce consumption of oxygen under controlling of our respiration. But when we will stop control of respiration, we will again turn back to the intercostal respiration for women. For